Okay, good morning everyone. So today, we will be learning the Mathematics 7 Module 9, the subsets of real numbers, lesson number 1. So to begin with, we have the set of objectives to follow. So we are going to describe and illustrate the real number system. We are going to classify the number of by naming set or sets to which or they belong using a Venn diagram. So, lesson number 1, illustrate the different subsets of real numbers. So, to begin with, let us discuss first the major words that are used in this lesson. First, we have natural numbers. This is the first subset of the real number. So, one of the subsets of real numbers is the set of counting or natural number. From the word counting, we are referring to the process of how we count. Example, we begin counting with 1. Next is 2, next is 3, next is 4, and so on and so forth. So this is our set of counting numbers. So the symbol for natural number is like this. So we have, it's like a bar then an N, and the set is 1, 2, 3, 4, 5, 6, 7, 8. We do not begin counting with 0. So we always begin with 1. So therefore, this subset consists of all positive integers that we use to count starting with 1 and so on. The subset would look like this, as what I'm showing, and so on and so forth. So the next is the whole numbers. Whole numbers. Another subset is the whole numbers. This subset is exactly like the subset of counting numbers that includes 0. The subset would look like this. So para lang siyang natural number wherein there is a 0 at the first element. So the whole number with symbol like that. So we have 0, 1, 2, 3, and so on and so forth. So that is now the elements of the whole numbers. Next, the integers. So the third subset is the integers. This subset includes whole number, not a fractional number that can be positive, negative, or 0. The subset would look like this. So um, integers may either be the positive number and their opposites or the negative one, and includes 0. But take note, this is not a fraction or a negative fraction or a positive fraction, but instead a negative whole number, a positive whole number, and includes 0. So we have integers. The symbol for integer is like this. So we have negative 3, negative 2, negative 1, 0, 1, 2, 3. Then do not forget the and so on and so forth. So we have now the set of elements with integers. So next is the rational number. The next subset is the rational number. So what is this rational number all about? So this subset includes all numbers that come to an end or numbers that repeat and have a pattern. Examples of rational numbers are 5.34, 6 over 7, 0.13, 13, 13, and so on and so forth, and the whole number 9. So the rational number has the symbol Q with C at the middle, then positive. So this the elements of a rational number are all numbers that repeat and have a pattern in its decimal, and at the same time the whole number itself. So the symbol for whole number is a rational number, rather, is Q then plus. Next, the opposite of a rational number is what you call irrational number, and it has the symbol Q minus. So what is this irrational number? Uh, this subset includes numbers that cannot be expressed as a ratio of two integers. Ibig sabihin, these numbers that decimals with no repeating patterns. For example, the pi, the Euler number, and square root of 2, and others. So those are the examples of these. So let's have a figure of the subsets of real numbers. If you look at the figure, we have the natural numbers as the most or the middle part. And if we add 0, it became a whole number. And if we add negative or the opposite of it, became integers. And if these integers um, includes the denominator 1, invisible 1, or a fraction of it, it became a rational number. And opposite to that is an irrational number. And all of these rational numbers and irrational numbers became real numbers. Now, is there a possibility that a natural number became an irrational? Of course not, because they are in a separate circles. Now, is there a possibility that a natural number can be a real number? Yes, of course, because it encompasses the circle of a natural number. Next, is there a possibility that a natural number became a rational number? Yes, of course. Next, is there a possibility that an integer became a natural number? Not all the times. So that is how to explain this figure all about. Another example, is there a possibility that a whole number became a natural number? Yes, but not all the times. Okay, let's have an example of that. So we have the first given square root of 3. Let me write it here. I know not square root of 3 but negative 3. We have negative 3, 0, 4 over 7, square root of 64, 13, and so on and so forth. So we have, let us check if it is a whole number, an integer, a rational number, or an irrational number. And let us also include a real number. So, sorry for my camera, it is not okay. So let's find out if it is a whole number, an integer, a rational number, an irrational number, and a real number. So negative 3. Of course, from the symbol itself, negative. Therefore, it is considered an integer. And if we go back with our figure, so an integer is also a rational number and at the same time a real number. So look at that one. So therefore, we also going to check rational and real number here on this side. Next, 0. 0 is part of a whole number. So therefore, we check whole number. Allow me to box it to make it an accurate, sorry. So that we could make it a table. Then, so 0 is a whole number. So let's go back with our figure. So a whole number can be also an integer. So therefore, we could write 0 on integer because 0 is part of the integer. At the same time, integer can also be a rational number because it has the invisible 1. And at the same time, it is always a real number. Okay, next. The next example is 4 over 7. If we are going to use your calculator, 4 divided by 7, we have, I'm sorry, 4 divided by 7, 4 divided by 7, we have 0.57142857, and so on and so forth. So these numbers will not end. So therefore, we could say that this one is a rational number. And all rational number are real number at the same time. So square root of 64. Square root of 64 is a perfect square with the answer 8. And 8 is a whole number. At the same time, it is an integer, it is a rational, and it is a real number. If you go back on our figure. Okay, next. Square root of 13. I know, 13 rather. 13 is a whole number. A whole number is also an integer. An integer is also a rational number and a real number. So that is an example. Those are the examples of subsets of real numbers. So thank you for watching.